Dear students, in this session, we will discuss how to test the significance of one population mean when population standard deviation is unknown. Sigma is unknown. And remember this, in most cases, population standard deviation is unknown. This is because the population itself is unknown to us. So population standard deviation is unknown. So to develop a hypothesis testing procedure, when population standard deviation is unknown, we consider a procedure which we have developed earlier. That is, we use what is known as the t-test procedure. Now, if a variable x of a population is normally distributed, that is, if x is normally distributed with a mean mu, then for samples of size n, the studentized version of x bar is equal to, the studentized version of x bar is t is equal to x bar minus mu by s by root n. If x is normal with the mu and sigma square variance, x bar is normal with the mu and sigma square by n, z is equal to x bar minus mu by sigma by root n. This is the standardized version of x bar, and this is the studentized version of x bar, where sigma is replaced by s, and this quantity follows t distribution with n minus 1 degrees of freedom. As discussed earlier, the studentized version of x bar follows t distribution with n minus 1 degrees of freedom. So we can perform a hypothesis test for a population mean when sigma is unknown using what is known as the t distribution. Instead of using z, we use t distribution for hypothesis testing. The only difference is z is replaced by t. Z distribution is replaced by t. And also, for the null hypothesis h0 mu is equal to mu 0, this t is equal to x bar minus mu 0 by s by root n. S by root n. That is the only difference. And also, we can take a decision about whether to accept or reject h0 by comparing the empirical t with the critical t values. And the procedure is known as one mean t-test or one sample t-test. The procedure is known as one sample t-test, popularly known as one sample t-test. Now, as in the case of z tests, we can use either the critical value approach or what is known as the p-value approach. In the critical value approach, the value of t is divided into an acceptance region and a critical region, and we compare the critical value with the value of t obtained from the sample. If the value of t obtained from the sample is in the critical region, reject h0. Otherwise, do not reject h0. As an example, if n is equal to, say for example, 21, degrees of freedom is equal to 20. For degrees of freedom 20, and alpha is equal to 5%, the critical t values are 2.08. 2.08. So, the critical t values, the distribution of t, for a two-tailed test, the critical t values are plus 2.08 minus 2.08. This is the acceptance region, 95%, 2.5, 2.5, the critical region. In an application, if the value of t is equal to say 5.8, 5.8 is here, we reject H0, mu as equal to mu 0. Mu is equal to mu 0, the null hypothesis is rejected. So, in the t-test procedure, if we are using a two-tailed test is if H1 mu not equal to mu 0 type, or we can have a left tail test like this, minus t alpha, 5% in one side, and a right tail test plus t alpha, 5% in the right tail, like this, the critical values. Our decisions depends on whether the empirical t is in the acceptance region or in the critical region. As in the case of the Z test, the only difference is, in the case of Z test procedure, we use the t distribution. In the case of Z procedure, we use the Z distribution. In the case of sigma unknown, we use the t-test procedure. The test statistics is now t rather than Z. The test statistics is now t rather than Z. And the critical values are provided in the tables, and also all the softwares will automatically compute critical values for you, or p values. And if p is less than or equal to alpha, reject H0 as usual. And if you are using the t-test, remember a point. As I told you, for 20 degrees of freedom, the t distribution is like this, and alpha 5%, it is 2.08 minus 2.08, and above this there is the distribution of what is known as x bar. Now x bar is converted into t, like this. But this is mu, this is not a mu plus or minus, this is not a mu plus Z alpha by 2 sigma by root n, this is mu plus t alpha by 2 S by root n. And here it is mu minus t alpha by 2 S by root n. That is the difference. Not and for 5% it is not 1.96 sigma by root n. It is 2.08 if degrees of freedom is 20. After degrees of freedom is different, you will get different values here. So instead of 1.96 for alpha level of significance, you will have different values here, mu plus or minus t alpha by 2 S by root n. And here also the critical values will be different depending on what is known as the degrees of freedom for a given level of significance. For a given level of significance. In an application, if the value of t obtained from the sample is, say for example 2.5, reject H0, say 1.8, accept no, do not reject H0. Or rather than saying accept H0, we say do not reject. Because our decision to accept H0 is based on sample evidence, and it is not free from or it is not 100% sure that H0 is true beyond any doubt. So this is the one sample t-test procedure. And remember this, we will consider these procedures using real data and statistical softwares.